last clip here, we're going to talk about the buffers. Sorry. So we have buffers. We've talked about them. What they do is they absorb or they tie up, however you visibly see it. But what they do is they help control the acid and base in our blood by absorbing the hydrogen or hydroxyl ions so that they're not free floating. We talked about bicarbonate ions and carbonic acid as the main ones, and those are extracellular. Intracellular, we look at phosphate and hemoglobin as being the intracellular ones. Um, now some discussion about what happens with the lungs and how they help with pH. So when we exhale, we breathe out carbon dioxide and water, and both of those are byproducts of cellular metabolism. And if we leave carbon dioxide to build up in our body, it can help us build carbonic acid, and that in turn turns into an acid molecule for us. So in order to remove carbon dioxide, what it does is it goes inside the red blood cell, and it finds a water molecule and becomes carbonic acid, and then it splits into hydrogen and bicarb. And when it gets to the lungs, I'll just go back to that. What happens is this hydrogen, it floats along, and it's good, and it combines with hemoglobin inside the cell, so it's not causing any damage, and bicarb swims along in the plasma. And at the lungs, everything reverses itself, and carbon dioxide is exhaled. The level of carbon dioxide in the blood is directly related again to carbonic acid concentrations. The less carbon dioxide we have, the less carbonic acid we can make. We increase our rate of respiration to get rid of carbon dioxide, and that in turn does not allow us to make carbonic acid and our acid level or hydrogen levels controlled. On the reverse of that, if we decrease our respiratory rate, it increases our carbon dioxide in our blood and increases our carbonic acid, and therefore we have more acid on board than we should. This is all controlled automatically because of the respiratory center in our medulla oblongata. That's where our autonomic service portion is. So when we have an increased carbon dioxide, it sends a message to that part of the VCR, which is the vasomotor, cardiac, and respiratory rate. And in turn, what happens is it increases our respiratory rate to stimulate the rate and depth of respirations, and then we exhale. Likewise, our respirations then are inhibited when our carbon dioxide level is normal. If we hypoventilate, carbon dioxide builds up in our body. If we hyperventilate, we lose carbon dioxide. We can also eliminate some hydrogen ions renally by the secretion of hydrogen ions in small amounts in the renal tube. Combining with ammonia to become ammonium, we can get rid of some there, and excretion of weak acids. But that takes longer and to kick in. Days to weeks to work maximally. The main role of the kidney in pH is to control our bicarbonate ions, and that's what its job is. It looks after bicarb better than anything. As we said on the previous slide, it does help us eliminate a few to help out the lungs, but this is less efficient than the control of bicarbonate ions. Just look at this slide here. This slide is just again recalling, our main extracellular electrolytes, and primarily you can see that sodium, and our main intracellular electrolytes is potassium. Although all spaces have some of all electrolytes, we have larger amounts in certain places. So you see chloride is another big one right here. So that